What did bro send? Okay, so this is a lesson about logic gates. I'm gonna. This video is mainly for revision because I expect every one of y'all to already know all the different kinds of logic gates that you need to know. Uh, so I will discuss about logic gates very briefly in this video. If you would like to have me have a more in-depth explanation about all the logic gates, you can just ask me. Okay, so logic gates basically take in inputs which are logic inputs and gives out inputs. Okay, that's it. That's a logic gate. For the logic gates that is in our syllabus, they have 1 to 2 inputs, max 2 inputs, and they have one and one output only. There are some logic gates out there with multiple inputs and multiple outputs, but we're not going through that today. Okay, so what is a logic gate? As I've said, there are inputs and there are outputs, um, and depending on the inputs, the output will vary. So let's say I have a mystery logic gate, okay, and there are 2 inputs and there's 1 output. Let's say if the first input is 0 and the next input is 1, and then let's say the output is 0. That's a logic gate which we don't know. Okay, then how about now when I say that the input is 1, then when both inputs are 1, then the output is 1. That's also a logic gate. Alright, so that's basically a logic gate, but uh, that's I'm not specifying what logic gate is. So I'm going to tell you the 3 basic kinds of logic gates, and then I'll get to the more unique logic gates. And by the way, you must know all the logic gates that I will mention in this video today. So the first logic gate is the only logic gate with 1 input and 1 output that we will be learning, and it's called the NOT gate. Alright, so the NOT gate has 1 input. The symbol looks like this. This is a symbol, and there's 1 output. And the truth table for this logic gate is as such, where the input, uh, the output is simply the inverse of the input. So if A is 0, then X is 1, and vice versa. Alright, this is a truth table. If you don't know what this is and you need to revise, or if you want to learn what this is, if you don't know, you can watch the video about truth tables. Alright, so this is the first basic kind of logic gate, the NOT gate. The next basic kind of logic gate is the AND gate. What the AND gate is it has 2 inputs, A and B. I'm calling it A and B. And the symbol looks like this. So it's kind of like a bar and then the letter U. Alright, and it has 1 output. And the truth table for this is like this. A, B, X, and this. Alright, so the condition for the AND gate output is both A and B must be 1 for the output to be 1. So for the rest of these, it's just 0. That's the AND gate. The last basic logic gate is the OR gate. Okay, so the OR gate, again, 2 inputs, and the symbol is like this. Like that. So it's kind of like a U, but not that long. It's just a short U, and then a longer U, like this. This part is very important to differentiate between the AND and OR, so please don't forget it. Alright, and the OR gate's behavior looks like this. As long as one of the inputs are 1, the output will be 1. And those are the 3 basic logic gates, alright? So let's go into the more unique ones. There is a different type of AND and OR gates that simply just inverse the output. Alright? So and these are the NAND and the NOR gates. Alright? So I'll just copy this. Let's go through the NAND gate first. Alright? The symbol is very very similar to the AND gate, but after this part here, there's a ball. Alright? That's for NAND. And the behavior is as such. Let's draw the truth table again. ABX. Let's draw all the possible configurations for A and B. Alright. So, as I mentioned previously, it's just the inverse of the output. So instead of 0, 0, 0, 1, it would be 1, 1, 1, 0. There. Okay? Now for the NOR gates. NOR gate. Yes, NOR gate. Again, the symbol is pretty much the same except for this little ball at the tip. And if you couldn't guess, the output is just inversed. So instead of 0, 1, 1, 1, it would be 1, 0, 0, 0. And these are your NAND and NOR gates. There. For the last set is a special kind of logic gate. It is the XOR, exclusive OR, but you can notate it by saying XOR, XOR, XOR. No one says XOR or XOR, it's XOR, okay? And it looks similar to the OR gate, the symbol, but it's just that there's an extra line here. And this is the XOR. Okay, so what is the behavior of this special gate? Logic gate, yeah. So it is as such. Alright, wait, let me just draw the configurations and the lines. When it's both 0, it's 0. Then it behaves like an OR gate for a while. But when both inputs are 1, it is 0 as well. And that's the XOR gate. There is still one more gate that you must know. Looking at the pattern, what do you think it is? That's right. It's the XNOR gate. Amazing. So, I'm very sure you can deduce the behavior at this point. It's just the same as the XNOR gate, except there's this little ball here. And the output is inversed. So instead of 0, 1, 1, 0, it's 1, 0, 0, 1. Yes. Oh crap. Okay. And these are all the 7 logic gates that you must know. Okay. Thanks for joining in. How do I leave?